Okay, so this is chapter 23, the rates chapter of my book, Overcoming Digital SAT Math. If you have a copy of this book, I recommend that you attempt the problems on your own first, timing yourself 1 minute per question, and then attempt the corrections on your own first before referencing this video for explanations on anywhere that you're stuck that you can't figure out how to correct it on your own. That'll get you the best results. And then also pay attention to each video description over time. I'm going to add updates or links to other related videos that you might find helpful to watch as a lesson or something before doing this, things like that. Or just extra practice sets. So let's start with number 1, pause to read if you haven't already. So if we're thinking of the rate that each of them is making a study guide, Maria is M. Her rate is going to be 1 study guide every 6 hours, so 1/6 is her rate. And then Josefina is going to be 1 study guide every 9 hours, so 1/9. And then, so if we want to find them working together to complete 1 study guide, think of this formula that quantity is equal to rate times time. So the quantity would be the number of study guides, which would be in this scenario 1. And then if they're working together, what we're going to need to do is add the rates together. So 1/6 plus 1/9, and then times the number of hours, which we're just representing with that variable t. So now I need to have a common denominator. So I'm going to multiply by 3 on top and bottom there and by 2 on top and bottom here so that I get a common denominator of 18. So then I'm going to get this. And then now I'm just going to combine that to get 5/18. So I get 1 is equal to 5/18 t. Now I just need to multiply by the reciprocal to get t by itself. So I'm going to multiply each side by 18 over 5. So I'm going to get 18/5 is equal to t. Now I need to turn that into hours and minutes. So how many times does 5 fit into 18? Well, it fits in 3 times at most. So it definitely can't be D. So it's going to be 3, and then you're going to have 3/5, because there's 3 left over. It fits in 3 times. 3 is the remainder. Put that over 5, and you have 3 3/5. So now I need to turn this part into the number of minutes, because this is saying 3 whole hours and then 3/5 of an hour. So 3/5 of an hour means I'm taking 3/5 of 60 minutes is how I could think about that. So I could say I'm doing 3/5 times 60. Well, 5 goes into 5 once. It goes into 60 12 times. 3 times 12 is 36. So it's really 3 hours and 36 minutes. So the answer would be C. Okay, pause to read number 2 if you haven't already. So what I find helpful is to kind of work backwards with these types of problems using stoichiometry. So I put at the end what I want my final unit to be. That's how I decide to set up the end of the problem. So I'm looking for how many gallons. So my ending unit needs to be gallons. So I'm going to keep that in mind. And I'm going to kind of work backwards to cancel out the units I don't want, which I don't want to have minutes. So I'm going to think, okay, how can I cancel out the minutes? Well, I could say that there are 60 minutes in 1 hour. That cancels out minutes and minutes. And then I could say, 3 hours is the specific scenario that I'm referring to right there. So I could use that information, multiply by that to cancel out hours and hours. And then all I have to do is multiply 3 times 60 times 27 and then divide by 45. And then I have my gallons. And that ends up being 108 gallons. Now, of course, you can do this logically, and you could probably figure that out. But what I find is that most students prefer the working backwards method because it's kind of a mindless sort of thing, strategy where you don't have to spend a ton of time thinking through it. And you could just kind of look at the units to help you. So whichever you prefer is fine. And pause to read number 3 if you haven't already. So again, I'm going to use that same strategy where I'm going to start with the units technically like start the problem off doing this with the units that I want to end up with. Because at the end, I want to keep the units of shoes. So I'm kind of like working backwards. So I'm going to say, okay, that means I have to cancel out this hours unit. So how can I do that? Well, it says that the factory is producing shoes nonstop from 10 a.m. to 3 p.m. So how many hours is that? Well, that's going to be 5 hours. So I'm going to say, I'm going to multiply by 5 hours. That'll cancel out these units right there. So then I just have to do 5 times 400 to get the number of shoes. And when I do that, I get 2000 C. Okay, pause to read number 4 if you haven't already. So again, use the units to help you. We want to find the average speed in miles per hour, so that means we want miles over hours for our units. So let's just put the miles over the hours. So we're going to do 2,100 miles over 3.5 hours. So just divide 2,100 divided by 3.5 and you'll get your answer. And the answer is 600 C. Okay, pause to read number 5 if you haven't already. So they start with half a tank. So I started by writing half a tank is meaning that they have 10 gallons because a full tank holds 20 gallons, right? So then I could say, okay, 10 gallons times 40 miles you get per gallon. That'll help me cancel out these gallons. So then that tells me how many miles they can drive with that half of a tank. So that's going to be 400 miles that they can already drive with that amount. And remember, the whole entire trip is 2,400 miles. So they already have those 400 miles that we're talking about, right? Then they're going to make one stop. So I'm kind of showing you how to do it like the logical way with this problem instead of like the reverse stoichiometry way. But again, you're free to use any method. I'm just kind of trying to switch it up to show different methods. So then they're going to stop, then they fill it up, and remember, each time they fill it up, the gas tank all the way, fill up the gas tank all the way, it's going to be 20 gallons. And then, as always, there's going to be the 1 gallon is equating to 40 miles that they can drive. So this is going to cancel out right there. And then I'm going to have that they can drive 800 more miles before they have to make another stop. So then there's going to be one stop after 800 miles here. So let me repeat that because I think I had like a little tongue twister moment. So they're driving, right? They're going on this 2,400 miles away trip. So they already have the half tank of gas, which means they can drive 400 miles. And then there's going to be a time that they have to stop. So they're filling up and stopping. And then they're going to have to do, now they have like a full gas tank, right? Which contains 20 gallons, right? And so that means that they can now, after that stop, drive 800 more miles before they have to do another stop, right? And then once they fill up at that stop, they're able to go another 800 miles because now we know, well, every time that they fill up the tank fully after each stop now, it's going to be 800 miles more that they can drive. So now they have 800 more miles and then they have to stop again. So now we're at 400 miles, 800 miles, and 800 miles. So if we add all of that up, what we're going to get is 2,000 miles that they've driven, right? Remember, we have to get to 2,400. So now they're going to do that one stop, and now they're able to go another 800 miles, which will take them past the 2,400 mile mark, I guess, or distance. So that means that in total, they would have to stop a minimum of 3 times. So the answer is C. Okay, pause to read number 6 if you haven't already. So let me show you how to do this one logically as well. Again, you can do the whole stoichiometry thing if you prefer. I'm just trying to switch it up. So if it can print 30 pages in 1 minute and we want to find out how much it can print in 2.5 hours, let's start by thinking, okay, 30 pages every 1 minute, there's 60 minutes in an hour, right? So that means in 1 hour, it's going to be 30 times 60 would give us the number of pages. So we can multiply that and get that it's going to be 1,800 pages in 1 hour. Now we just need to find out in 2.5 hours how many pages would it be. So we just have to now multiply that by 2.5. So that's what we're going to do. And remember, you can put this in your calculator. It's a digital SAT exam. Or you could see that obviously, like even just by estimating, it has to be D. So that's the answer. Okay, let's try number 7. Pause to read if you haven't already. So think of the formula distance equals rate times time and plug in your given information and then solve for t, like this. So the rate is the 3 miles per hour, the distance would be 15 miles, and now we just need to isolate and solve for t by dividing by 3 on each side. So when we divide by 3 on each side, we're going to get that t is equal to 5 hours. B. Okay, pause to read number 8 if you haven't already. So I want to end up with clocks as my final unit, so if I'm working backwards, I'm going to start with this relationship right here, 10 clocks every 1 hour, and then I want to cancel out hours. So I have to think, okay, how can I do that? Well, I want to figure out eventually how many clocks the company will make in a week. So I'm going to think, okay, how can I get from hours to weeks? So I'm going to think, okay, there are 24 hours in a day. So I could say 24 hours in 1 day is another relationship I can use and cancel out hours and hours. And then now I want to cancel out days. So how many days are in 1 week? Well, there's going to be 7 days are equivalent to 1 week. So this cancels out right there and there to leave me with just the number of clocks. So I'm going to multiply all that to get my answer. And then the answer would be C. Okay, pause to read number 9 if you haven't already. So area of a circle is going to be equal to this formula, where A is the area and R is the radius, right? So let's first figure out the area when the radius is 4 feet. So I'm going to plug in 4 for my radius, and then I'm going to square it to get 16 and then multiply by pi. So it would be 16 pi for that area right there. Now let's determine the area in the second scenario, where the radius would be 8 feet. Well, the area would equal pi times r squared, which would be 8 squared. So that's going to be 64 pi. So remember, we're going from this area to this area. And you can see that there's a relationship here where we're multiplying 16 pi by 4. Like the area is 4 times greater. So that means the time should also be 4 times greater. So 3 times 4 is going to be 12. So 12 minutes. Okay, pause to read number 10 if you haven't already. So if we think back to the formula, distance equals rate times time, the speed would be the rate, right? R. Now, if we divide each side by t, we get r by itself, which is what we're solving for, right? So to find the rate or the speed, we need to find the distance divided by the time. Well, we have the total or overall distance already. It's going to be 200 plus 300 miles. So the only semi-tricky part here is to figure out how many hours we are talking about. So let's do that. Let's focus on the first situation with the 200 miles at 40 miles per hour. So 200 miles times 40 miles per every 1 hour, that would cancel out miles and miles and give you the total number of hours for the first portion. So when we do that, we get 5 hours. So now let's do the same thing for the second part of the situation, 300 miles at 60 miles per hour. So 300 miles times, and then it's going to be 60 miles every 1 hour. Miles and miles cancel out. So then here, if we do 300 divided by 60, we're going to get 5. So there's also 5 hours in this situation. So now let's refer back to rate or speed is equal to distance divided by time. So if we put the overall distance, it's going to be 200 miles plus 300 miles that Jennifer drove, and then it's going to be 5 hours plus 5 hours for the time. And then all we need to do is solve that to find the average speed in miles per hour. And when you do that, you get B, 50 miles per hour. Okay, pause for number 11 if you haven't already. So I'm going to do the backwards stoichiometry method. So I want to end up with weight in pounds. So that's why I'm starting with this relationship right here. And then I want to work backwards to cancel out the ounces. So let's see what other relationships I can use to do that. Well, it says that it's $1,806 per ounce. So I could say one relationship that I have is that for every 1 ounce, it's going to be $1,806. So that would cancel out ounces and ounces. And this is in dollars, right? So I want to cancel out dollars now. Whoops, I meant to put multiplication. So now I'm going to see, okay, how could I do that? Well, I could just multiply by the 144,000. So that's what I'm going to do. So I'm going to do 144,000 divided by 1,806 and then divided by 16. And when I do that, I'm going to get 4.98 yada yada yada. And I just realized on the key that this does not extend out to 5 characters. So it's 4.98338 yada yada yada, and then we would actually cut it off at 4.983 because this would be 1, 2, 3, 4, 5 characters because the decimal counts as a character. I must have forgot to type the 3. Sorry about that. That'll be fixed on the new edition that I release after I release all these videos. Okay, pause to read number 12 if you haven't already. Okay, so we want to know how many loaves of bread he would have to sell. So we have to think, okay, what you sell it for minus what you buy it for is going to give you your profit, right? So if you look at what it's selling for, it's going to be that he's selling for $16 4 loaves of bread. So $16 for every 4 loaves of bread means if we turn that into a just per 1 loaf of bread situation, it's going to be that it's $4 for every loaf of bread that he sells. So he's selling each loaf of bread for $4. So he sells for $4 each. And then if we do a similar situation with the buying of the 5 loaves of bread for $10, that means that it's $2 for every loaf of bread that he's buying. Like he's buying each loaf of bread for $2. So that would be the rate he's buying at, right? Now, if you subtract that, you're going to get $2, right? 4 minus 2 is $2 in profit for every loaf of bread that he ends up selling. So we would do 2 times X will be our number of loaves of bread, and that's going to equal 144 for our profit. Now let's just divide each side by 2, and that'll give us that X is equal to 72. Okay, pause to read number 13 if you haven't already. So let's do this the reverse stoichiometry way. So I want to end up with envelopes as my final unit, so that's why I'm starting with this at the end of my problem. So I want to now work backwards to cancel out centimeters right now. So I see that there's a relationship of 1 meter equal to 100 centimeters, so I'm going to use that. So I'm going to say 100 centimeters goes on top, that way these will cross cancel for every 1 meter. But now I need to cancel out meters. So how am I going to do that? Well, each roll of tape contains 7 meters of tape, so I'm going to use that relationship. 7 meters, 1 roll of tape. So meters and meters cancel out. Now I need to cancel out rolls. Well, we're specifically using 2 rolls of tape. So I'm going to multiply by the 2 rolls to cancel out rolls. Now I just need to do 2 times 7 times 100 divided by 5, and that gives me the maximum number of envelopes. And when I do that, I get 280 as my answer. Okay, pause read number 14 if you haven't already. Okay, so what I did was I set an arbitrary price. So I just picked 5 because all the numbers I saw in the problem were divisible by 5, so I figured probably an easy bet to go with that. So I'm going to just say that the price is $5 per gallon. It's not going to change. And then I said I'm going to set up a problem to figure out how many miles Karen is originally driving with the old motorcycle. So I started with miles on top right over here so that I keep that unit. And then I used the relationship of 35 miles per gallon with the old motorcycle to cancel out gallons and gallons here by using the relationship also of 1 gallon for cost $5. And then I'm now going to cancel out the dollars over here by saying, oh, with her old motorcycle, she's spending $200 monthly on gas. So then dollar and dollars cancel out. So then you're going to do 200 divided by 5 times 35. You could also say 5 goes into 5 one time. It goes into 35 7 times to save yourself some work. So it's just 200 times 7, which would be 1,400 or 1,400 miles. So we know that the distance and the price is not changing. So let's use that information for the new scenario with the new motorcycle, which is covering 50 miles per gallon of gas. So I want to end up with dollars as my unit, like how much she's spending monthly for gas for the new motorcycle. So I'm ending here. So now I need to work backwards to cancel out any unwanted units. So I'm just left with dollars at the end. So let's look out for a relationship with gallons. Well, I know that with the new motorcycle, it's getting 50 miles per gallon of gas, so let's use that. So now I can cancel out gallons and gallons, and now I just need to figure out how to cancel out miles. Well, I know that the distance is going to be 1,400 miles, so let's multiply by that. And that'll cancel out miles and miles. So now I'm going to do 1,400 divided by 50 times 5. And that would give you B $140. Pause to read number 15. So I want to find the distance it'll travel in 2 hours, and the distance needs to be in kilometers based off of the answer choices. So my final unit should be kilometers. Side note, I feel like I say that wrong. Is it kilometers or kilometers? I'm having like a moment. I feel like I usually say it kilometers. Okay, sorry. Okay, so we're going to end up with kilometers on top, and we're going to work backwards to cancel out unwanted units, which in this case right now we have minutes that we don't want. So there are 60 minutes in 1 hour, so that cross cancels, and then now we can say, okay, we're going to multiply by 2 hours, and then the hours will cancel. So you're going to do 2 times 60 times 45 divided by 20 to get the kilometers. And when you do that, I cannot speak. When you do that, you would get 270 kilometers. Oh my gosh. Or kilometers. I don't know. That's tripping me up. Okay. B. Okay, pause to read number 16 if you haven't already. So 4 burnt for every 250 total bagels is directly proportional to the mystery amount burnt bagels that we're solving for out of the total 25,000 bagels that are made each day, right? So how do you get from, I mean, you could cross multiply, but I just automatically see, okay, to get from 250 to 25,000, I need to multiply by 100. So then I have to also do the same to the top to get to this mystery number. Well, what's 4 times 100? That's 400. So 400 would be your answer. Okay, pause to read number 17 if you haven't already. So this is just a simple plug-in problem, so they even give you the equation, and then you're trying to find the distance, so D, you're basically solving for D, and then you're going to plug in 3 for T. So D is equal to 25 times, instead of T, we're going to say 3. So then that's just going to be 75 miles. That's your answer.